Okay, so today I actually have only a short time to do this before I have to leave. Oh shit, about 45 minutes, which is not a lot of time at all. But what I want to do is to try to get used to PyMC3, which is a Python computing library for inference, statistical inference. So things like not necessarily statistical inference, but variational inference, sampling, that sort of stuff. I've never used it actually. So actually, you know what? Let me see if we can get some music going. If we can get some music going. What's the thing? DMCA, is it? I dropped my subscription for Epidemic Sounds, so now I don't have proper music. Let's go with this. Chill lo-fi beats. Okay, whatever. Then we can hear them. Should really not be spending time on this. Alright, sweet, let's go. So my goal is just to oh shit, I just closed the am I stupid? Yeah, I don't know, I thought it's just gonna keep playing for some reason. Oh my god, no, that's my social media. Okay. Yeah, so the goal is just to set up a simple quick example, and then over the weekends I can run longer examples to verify my results against what I have already, because the results that I have is suspicious in that they look a bit too good to be true, and I agree. And I mean, my supervisor brought that up. I mean, of course, I noticed it, you know, when I have the results at first, but I figured, oh, you know, there's nothing wrong. But yeah, he made a good point that this is super strange, and I should make sure that my results are valid, really. So yeah, so I'm using is here. Yeah, has an implementation of nuts, so that's good. Hopefully this doesn't take long. Okay, let's just dive into it. There's a quick start. Let's do quick start maybe. Is there nuts here? Okay, cool. Let's go. You create using the model class. It has references to all random variables and computes model log probability, I guess, and its gradients. Usually you would instantiate it as part of a with context. Okay, so with PM model as model. Okay, we discussed random variables further, but let's create a simple model to explore the model class. Okay, so the model, what? Oh, wait, I'm confused. But there's no model in this, right? So the mu, so mu is some parameter. Ah, okay. I see. PM model. Okay, I don't really understand the syntax very well at this point, but let's just move on. So the basic random variables are mu and obs, free variable, and observe variable. That's interesting to put it. And the log p, it's worth highlighting the choice we made with log p. The log p is being called with arguments, so it's a method of model instance. More precisely, it puts together a function based on the current state of the model, or on the given state, or on the state given as argument. Okay. So you want to just supply to it the free arguments. Alright. For diverse reasons, we assume the model instance is not static. If you need to use log p in an inner loop, and it needs to be static. simply use something like log p equals model.log p. Here, note the caching effect and the speed up. Okay. So if I use this, I assume the second one is faster because you staticize it. Okay, so that means every time you run model.log p, you are doing some type of new computation, whereas this is taking those things fixed and then just using it as a as a function. Okay, I'm not super clear as what static means here. Is there a deeper specific technical meaning other than the fact that like static like Java programming, was it public static void main, the kind of things? Every program consists of observed and unobserved. Observed are defined by likelihood, unobserved are prior. Okay, so unobserved would be your, I guess, your free variables. So we have normal class, normal. The PDF is given by this. Okay. So wait. So this is a model. No, it's a normal. It's a class called normal. Okay. Methods, you have the log CDF, you have the log P, log probability, and then you can draw. Okay. PM distributions dot mixture. Every unobserved has the following calling signature, name, keyword arguments, thus a normal prior. So X is now a random variable that is unobserved. So that means it bears. I see. So if you do an observed one, you will need to supply the free one as well, I believe. Are defined just like, but require data to be. Oh, sorry, you require data to be passed in. Yeah. Okay, so observed is this. So this is the data. Okay. Oh, almost 30 minutes left, 35 minutes, 8 minutes left. Let's go. To freely do algebra with RVs in all kinds of ways. What the heck is this? Oh. Maybe I'm reading the wrong things. Can I just start with an example to see if there's any sense in that? Is there like a example? Okay, this looks very straightforward. So n, h, alpha, beta binomial. So n is just this, p is what you sample. pm.sample. So I'm actually confused here because I don't understand what this model means. I thought the way context manager works is that that you have a model and you should use that model as a variable, right? Or like a keyword, right? That's not a keyword, like a variable. So that means outside of this context you don't have this keyword or this variable. But there's no mention of model inside here, so I'm not sure what's going on actually. This is not going so well. Let me just see what's there. I'm sure people I'm sure people have tried this, right? I mean, isn't there like a simple example? Maybe example is the keyword. Sampler statistics? No, not really. Okay, I see this PM.nuts. Maybe I should look into this. Ooh, this looks correct. Sampler statistics. When checking convergence, blah blah blah. Model mu PM.nuts. What is PM.nuts? Then sample. So So you can think about with this model, or at least now I'm extracting it to be this way. It is a normal distribution where mu1 is a variable which has a normal distribution, 0 mean, unit variance, and I guess in 10 dimensions. And then with the model, you can take nuts as step as in I guess transition, and then sample 2000, tune using 1000 short chain, initialize nowhere, cores equals 2. Okay, I think how do I okay, let's jump right into it. I actually don't really need so many of these things open. Yeah, I don't know why my Chrome lags. Should I just maybe I shouldn't use Chrome. Let me try my great, that already it's a little. So it's Chrome? Maybe. Load people, come on, load. There's so many of these. And then I close them. Okay, whatever. Inference. Yeah, wait, where was I? Oh, okay, I'm still a little bit away. Should I? Okay, let me just quickly read this. So I don't know what this has to do with anything. I mean, I guess you just see what possible things there can be. Unobserved. So you define a variable, and then you can talk about the probability. If it's observed, you can also talk about the probability, but you need to supply to it data. And I'm guessing in this log p you need to supply the data for the observed. Okay. What do you call it? Well, what do we call this? Confirm nuts? No, re-ruts. nuts test, I guess. Doesn't really. Why am I hung up over this? I don't know. I guess. Okay. Do I have PyMC3? I think I do. Maybe I don't. Ooh, why taking long? Okay, cool. Maybe let me blow this up a little bit. Okay. Probability distribution. Okay. Okay, so let me try something then. When I say PM meaning PyMC3, right? It's called PM, right? Okay. PM, and then I guess I also import this as AZ. Okay, I don't know what this is, but it looks good. Okay, first I guess we try this. Okay, so this is using the model and then creating two variables, one free and one observed. And I'm not so clear actually. So I can talk about okay. So this makes sense. This is saying that, so it should be something like that. Okay. I wonder, can I do the same for ops? It doesn't make sense, right? Cause missing requirement. Yeah, okay. Yeah. This makes sense. So it requires my mu. So I don't know. 0. Does this make sense? Confused, huh? Oh wow, look at this. Very nicely put. So if I guess it matches the name. Yeah, so this is the name. Alright. Does this make sense? Yeah, okay, so the keyword cannot be an expression. Actually, what am I doing? Yeah, what the heck? And I just try to okay. Yes. So let's try if I can let's do 20. What? The log probability of ops being all these values given mu1 is 1. Log probability. I don't understand. Okay. So mu has 0. What's the point of this observed? Oh, okay. Wait. Then why do you need? So I think this thing doesn't matter because this is literally saying God damn it. Huh? So I mean this makes sense in that it is saying that the log probability of observing these things given mu equals 1 is some value. That's sensible. So if I change it, it's gonna be different. Okay. But then why am I required to put this? What does this mean? What does the 1 mean? Okay, I might be using it wrong. Probably I am. Okay. Deterministic transforms do linear algebra. Deterministic x plus 2. What the heck? Why do you need to write this down? What? While these transforms work seamlessly, their results are not stored automatically. You have to use PM deterministic. What? So plus 2. No, the plus 2 can be used in the identical way to above. We only tell PMC to keep track of this RV for us. Okay, so it's okay. So that means I can define one in terms of the other, I guess. So if you don't use plus 2, it's not kept tracked. What does that mean? That means if I change x, is it? That it wouldn't correspond to the... That makes little sense. In order to sample models more efficiently, automatically transform bounded to unbounded. When we look at... Oh, that's very good actually. The interval represents the x transform to accepted in case of the upper bound. Ah, yes, that's true. You can also turn the transform off. Okay, so now instead of x interval, you get x, just x. Oh. Why is it taking so long? So now I expect to see x interval and mu. Yes. And then if I do this, I should see x and ops. Wait. Deterministics. Huh? I don't know. Don't get. But okay, anyway, let's move on. Turn the transform off if you want. Okay. Transform. The user specified transformation is okay. Okay, I don't really need this for now. I mean, it's all very nice, but I don't really need it. There is a tendency to create lists and random variables. Bad. Good. So just use shape 10. Alright. We can index. Now that it's a random variable, we can index it into or do linear algebra operations on it. Very good. I'm not sure what this means when you say it doesn't keep track. But okay, never mind. Tries to automatically initialize models. It is sometimes helpful to define initial values. This can be done by a test val. Okay. I see. Okay. I'm not sure what initial value means. Does it mean the first sample? Like what is that what it is? Okay, let's do some sampling. The main entry point to sampling is sample function. Default, this function tries to auto assign the right samples and auto initialize if you don't pass anything. In 3.9 and above, which I am, the return inference data goes through keyword argument, makes the sample function return an RVis inference instead of a multitrace dot inference data has many and then we compare to a multitrace, can be saved, and also yes, I data sample, but how do I choose nuts? Assign that sampler, which is very efficient. Here we draw 2000 samples. If not set via the coarse keyword argument, the number of chain is determined from. Okay. You can also run multiple, and that's very beautiful. Ah, you have a bunch. Commonly used nuts are, besides nuts, are metropolis and slice. Nuts should be preferred. There are hard to sample models which nuts can be very slow and use metropolis instead. In practice, however, this is rarely successful. Nuts is fast but can be slow. In the case for yes. Okay, so step is kind of like transition. Alright, so now I know what to do. Is that Mala? So the point of HMC, of course, is that I need to pick the number of you can also assign variables to different step methods. What? What does it mean? What does it mean? So this is like a hierarchical model thing? Whoa, what the hell is this? Huh? Wait, you can do like that? So you're composing the transitions? Yo, that is cool. Okay. Plot energy. What the hell's energy? Okay, but that's a okay. Energy as in okay, energy as in like the Boltzmann Hamiltonian type of meaning. Okay, I guess It's a little bit scary. How do I find out how many steps it takes? I mean, this looks very good, but how does it work really? How do I find out the I guess I have to go into it. Oh, there's a tutorial segment. Jesus. And I didn't. What the heck? I'm stupid. Deep dives. Sample callback. Sampler. Ah, yes. So you gotta trace. Get wait, hold up. Get iData. Let me just see what the hell is going on here. Does it have that? No. Wait, what's the difference? Beautiful. I'm confused. So what are you sampling here? Can I change this? If I do like this, what happens? Say 1, 10, 100. So now I should expect more than one step, I guess. Okay, now, okay, 3 steps. Alright, now this makes sense. 3 depths. Okay. That's good. 3 steps. Right. Let's go with let's just say that it's mu equals to np dot log space what is the oh man, running out of time. It's okay. I guess I can be a bit late. Start, stop, num. Start, stop. Oh, not 10. So stupid. So this is 50 dimensional. And this is the trace here is a multi-trace variable, okay. And then now this number of steps is this in this kind of way. Sigma. See what happens. Oh, can I choose not to? I need to charge my devices. Alright. Okay, I'm almost there. I mean, not really, but how? The thing is, I don't want to jitter. As in, no. Adapt diag. Initialization method. Can I choose none? So initializing. Well, how do I say fix? Assign. Oh. Wait, did my speaker die? No. Well, okay, let's try something. Nah. Invalid syntax. What? What do you mean? Oh. Okay, this is fine. Okay, let's see if this works. Oh, there's some divergence. What is happening here? Yes. Whatever. Okay. Sure, okay. Let's now think about how to implement very good. how can I add a tune? Does it work? Oh. So if I don't add a tune, let me just try that again. Then the step size should be yeah. Oh, it's different also. Wait, what? Why is it different every time? Step. Wait, it's the step size. Hold on. The step size is, what the heck? Does it mean trajectory length? Step size bar. What the heck is step size bar? Average step size? Number of steps. What's the heck is steps? Because if I look at here, step scale. Can I check? The step size is 0.25. So what is it? What does it mean? Path length. Then what is step size here? The distance between the two, is it? I need someone to explain this shit to me, man. Scaling once more. Oh, automatically scaled down by 1 over divided by n². So it's 50. It's scaled down by. What? Stopping time. Okay, if I don't tune, what happens? 0.65. Okay, anyway, let's move on. I don't know if this makes any sense, but let's say that okay, I should be really leaving super soon. Not stat equals pm dot nuts. Does this work? It's not defined. God. Okay. Okay, so the point is that I wanna compute how much of the efficiency is different, right? Okay, so let's check a few things. So the I data, okay, very good. The I data should be taking some number of steps. It's gonna take a little bit to compute, I believe, but okay, you can see that it takes like, say, yeah, so I can take all these steps, and then the H data will be taking oh, a H is what? What? Wait, I don't compute. What? Wait, what? What am I? Okay. What? Okay, never mind. One last thing. Yes. Wait, but what the heck? Can I? Very good. Yeah, okay, I'll continue this another day. I gotta leave now, but yeah, this is a bit... I don't fully understand what I'm doing yet. Alright, but I gotta go.